Shake Table Lab by Henry Hansen and Katrina Blackman. This drawing is of what I thought our tower should look like before we started building it. Over the course of construction, many changes were made to the final tower. The first thing we did to our tower was to insert straws partway through the base plate and secure them down on the other side. That way our tower would stay still, and we bolted into the base plate. After building the base of the tower, we built the first and second floors and proceeded to stabilize them with extra straws. After the initial stabilization of the floors, Katrina and I added straws in the middle of the first floor and second floor to support more weight. When we were finished building the tower, we added a roof on top of it. That way the tower would look more artistic and effective. This drawing is of what our tower looked like after it was completed, and includes all of the dimensions of the tower. After completing construction of the tower, Katrina and I added sandbags onto each floor to see if they would hold the weight. They did very well. Before completing the tower, we wrapped extra pieces of tape around joints where multiple straws met. That way they would be supported more. The strongest parts of our tower were the pairs of straws that were inserted through the holes in the base plate and taped down from both sides. They held the most weight and stayed sturdy the longest. The weakest parts of our tower were the unsupported areas of it, like floors and supports. We did our best to make sure they were as secure as possible. Katrina and I tried hard not to overuse the tape we had. When we were finished with the tower, we colored some of the tape black to not make it look too tacky. There were not very many extra supplies that we were given. We were given some construction paper for the roof and flooring, and some extra straws for the roof. After we finished building our tower, we decided to put it on the shake table to test and see if it would withstand an earthquake's forces. Our tower held against the forces of an earthquake very well on the shake table simulator.
Well, it seems like you're shaking that a lot.
Our tower withstood the shake table very well, but eventually it collapsed at 14 sandbags when one of our supports gave in. It was very fun to watch our tower collapse.
Oh no. Oh, I just cracked it. Yeah!
This XYZ graph represents the motion recorded by a sensor put in our tower as it collapsed. The x-axis records the side-to-side motion, the y-axis records the forward and backwards motion, and the z-axis records the up and down motion.
Our tower successfully held 12 sandbags and collapsed on the 14th. Our building failed in one of the supporting corners. The corner didn't have enough tape or supports attached. With the wobbly corner, the tower gave in. Some changes that I would have made to our tower would have been to add more tape. When watching the tower, I could see tape lifting off the base and start to fall apart. If we added more tape, this would have not have happened. I would have also liked to put a support in the center of the first story to give it more support. I learned that you have to have a lot of supports in your tower and that building designs can change completely. I enjoyed being able to create something and then demolish it. I also really like being able to communicate with someone and then make a great project.
Our tower successfully held 12 sandbags and it collapsed on the 14th sandbag. Our tower failed near the bottom where one of our supports came loose due to loose tape. We could have strengthened our tower by strengthening the tape and adding more supports. I learned that there are a lot of things to consider when building an earthquake-proof building, and that I had a lot of fun collapsing the tower.